Hello everybody and welcome back. Today we're going to be taking a look at the next level of drawings in our course, which are the orthographic drawings, otherwise known as third angle projection drawings. So we're going to be starting with the feed stop. It says download each one of these files to your H drive. This is your drive on your computer at school. We're going to hit feed stop, download this. Click on it, hit open, and here we go. So you're going to notice that we have three different origins here in different spots instead of just having one, because we're creating three views in this drawing. It's almost like three drawings in one, even though all the views are meant to be together to be able to tell the story of this part properly. So we have three basic views. Our top view will go here, our front view will go here, and our right side view will go here. Clicking back into the hub, I'm going to go back a bit, and we're going to take a look at what we're going to be drawing. So if we scroll down to orthographic drawing problem handouts, we're going to find the feed stop here in a PDF document. So this is what we're going to be drawing today. So this shows you what it looks like in a 3D view, but the proper term for this is called isometric view. So again, we're going to be creating the front view, which is looking at the part in this direction. The top view, which is up and down here with my cursor on top, bird's eye view, and we have right side view, obviously to the right of the front view. We're also going to learn how to use the circle command today under draw tools, which is something we haven't looked at yet. And we also have here a little symbol next to the 64, 41, and 21.5. It's a circle with a line struck through it. So that symbol defines diameter. So on a drawing like this, whenever you see a symbol like that in a mechanical drawing, it means diameter. If you saw R, it would state radius. Now, the diameter symbol is a universal symbol, so it doesn't matter if your drawing is printed out in English or French, Spanish, or even Arabic. Someone on the other side of the world may receive an email of your drawing, may not speak your mother tongue language, but would look at your drawing and see that symbol and know that that stands for diameter. So the world of drafting has universal symbols, so it doesn't matter what language you speak. There's no barrier there. Anybody could take a look at your drawing. If they knew drawings, they'd know that that meant diameter. So that's just a little fact about that symbol there. You can see that there's a radius 7 here on this fillet, a radius 6, and so on. So we're going to continue on here and we're going to get started. So we're going to click into the drawing and we're going to start with circle. Now, this will want to default to radius. Make sure you're picking center diameter, and you can look at this leader here. It shows it going from center to the arc. A diameter goes from one side of the circle to the other side. So select center diameter, zoom in, select the end point on the starting point of the origin, and then key in 64. We're going to go back up, get the circle again, pick the starting point, and this next one is 41. Lastly, we have the smallest circle, and in the center, that one is going to be 21.5. Okay, got it. All right, so moving on. We're going to have to create what's called a center line in this drawing. Now, we talked about center lines in the template drawing. This drawing has more center lines to add, and these center lines are going to help us construct this part in these views. So what I'm going to do is start with a line, and I want to snap the top vertical quadrant of this circle, but I can't. It can only pick up the center. So what I want to do is turn a snap on. If I go down into my status bar down here where ortho is in polar, and I come over to object snap, if I right click and left click snap settings, I can turn on a snap I need here called quadrant. So this is going to pick up the quadrant of any circle. It's not something we've needed before because we haven't really drawn any circles before. So that's checked on. We're going to hit OK. And I'm going to draw a line from this quadrant down to the bottom. Right click, left click, enter. Okay, so looking at my iPad, which I have open next to my screen, from the center of the cylinder, or the circles, the end of the part is 85 millimeters away. So I'm going to create an offset, type 85, enter, and offset this line over to the right. I'm also going to create another line at this quadrant of the circle and bring it over to the perpendicular midpoint. Now, the iPad image tells me that the width of the bottom horizontal flange is 27 millimeters per side. So what I can do is grab an offset again, type in 27, offset this line up and this line down. Right click, left click, enter. And then what we can do is trim this up a bit. So this line should not extend beyond the radius of this circle. So we can grab a trim and select this boundary, right click, and then left click, right click, left click, enter to end the command. Now because this circle picked up this boundary as well, it didn't trim these two lines off. So what we can do is we can just select these, and this line here can be trimmed down to suit this line, or we can use a grip to bring it down. So this time I'll use a grip. I'm trying to use the commands I've shown you from time to time just to remind you that they're there and that they're there for you to use. Moving on, the top flange that sticks out vertically is 14 millimeters to the left. So we can select offset, type in 14, and then click to the left. Right click, left click, enter. And then lastly for this view, we have a radius, a slot that passes through the top flange. It shows that it's a radius of 6. So what we're going to do is do another offset, type in 6, and offset that in both directions. Right click, left click, enter. And again, we're going to have to trim up the access. So we're going to go trim, select this boundary, right click, and left click. All right, so we're going to leave this view like that for now. That view is almost complete. It is complete from a physical outline of what's to be manufactured view. The center lines still need to be finished and adjusted, but we're going to leave that for now, and we're going to get started with the front view now. So we're going to hit line command, and we're going to start at the origin in the same spot we always start, and we're going to make sure ortho's on, which it is, and we're going to come up. We're drawing the cylinder in the front view now, so we're going to type 50. That's its height, and it comes over 64. Now, what I could do, instead of typing 64 again, I can touch here, and I can use the O track, and the O track's going to find it at 64 for me. just make sure before you left click, you see that 64 there, you haven't made a mistake. Left click. All right, so I'm coming down. I'm going to touch the origin and O-track it, and then come back and type C, enter to close it. All right, so that is our cylinder done. Now, we have holes that are passing through the cylinder. So we have to show those. But because we're working in orthographic projection, those details are not going to be normally seen to our eye. So basically, those circles that represent depth, we couldn't see them by looking at this part of the cylinder, but we still have to show them, but we're going to show them as what's called a hidden detail line. So this is something that is practiced in the Drafting Fundamentals module that is done with grid paper and pencil. So we're going to grab our line command, and we're going to start with the most inner circle, so that this circle passes right through the entire cylinder. So what I can do is just draw a line from there and come down to perpendicular, right click, left click, enter to end. And then I can right click, left click, repeat, do this again. And then what I can do is I can trim this. So this is the boundary. So basically what I'm doing is I'm using the top view to help me build this front view. The next size circle is 41, and it's 12 deep. So what I can do, right click, actually I want to start again with line, so line, pick this quadrant, come down to perpendicular. We're going to repeat that again. And then this time, we're going to offset the depth. So the depth, it says that the 41 diameter hole is 12 deep. So we're going to type 12 and offset this line down. So now we're going to do some trimming. So we're going to select trim, select this line as a boundary, trim those lines off. This line here could be trimmed or gripped back to this perpendicular snap. This line can be trimmed or gripped up like this. And then this line can be gripped to this perpendicular snap. And that's what we have. So we have the smaller hole that passes through and the larger hole that only passes and comes down about 12 millimeters deep. One last step is to, now that all this is selected in grip, I can go up to my layer manager and select hidden line from the drop down. And what that's going to do is change the layer to something lighter and an evenly dashed broken line. Right? Because anything that you normally can't see on a drawing has to be shown in hidden detail. Now this might be hard to see on the projector, so I'm just going to change the layer property. I'm going to change the color. You don't have to do this. I'm just doing this to help make this more clear. We're going to change this to yellow so this shows up a little better. Okay. Now, when I look at this from the front, this is what I'm going to see. Now, when I look at this from the right side, again, this is exactly what I'm going to see. This is a cylinder. So if I look at a cylinder from the front or the right or from any direction, it's going to look the same from any perspective. So I need another one of these on the right side view. But again, why would I redraw it? I already have it. So if it's going to look exactly the same on the right, I might as well just copy it. So that's what I'm going to do next. I'm going to go to the copy command, select the objects, and when I select the objects, I don't want to select the origin because I got an origin in here. I don't need to copy that twice. So I'm just going to stop around here and then select this bottom horizontal line making sure I didn't touch where the origin is. So I'm not copying the origin, I'm just copying what I've drawn. I'm going to right-click my mouse, specify base point, well, where the origin is at this bottom end point, and bring it over to the origin starting position endpoint here and click. Right-click, left-click, enter, and that cancels the command. Okay, so now I have two of them just as quickly and accurately as that. I'm still not done yet. I still got a few things I need to do here. So next up is I need to continue to build my front view. So what I can do is use a grip, stretch this line out, and then again touch this endpoint, and this is going to find, this O-track is going to help me find the end of the front view. I don't have to worry about inputting a number when I use an O-track. This is the beauty of the O-track system. So I can just, it's picked it up. It says that it's 53 millimeters beyond the end of the cylinder. So I'll left click and I have it. I'm going to go and get my line tool again, start at this endpoint, and this vertical flange comes up 33 millimeters. So I'll type in 33, enter. And again, I don't need to type in the 14 millimeters. I can just O-track it. Come up like this. And I can come down to here, which is too much. Next up, we're going to offset this line up 14. Select offset, type in 14, enter, offset this line up. And what we can do is trim the rest or use a grip. So I'll use a grip, bring this back to this perpendicular snap, bring this one up. All right. So this horizontal base basically runs into that cylinder, but there's no dimension on the drawing that tells me where it runs into the cylinder and where it begins. So what I have to, I am actually forced to use the top view to help me finish this front view. I have to know where to trim this horizontal line off. So what I can do is grab a line, find that endpoint, and draw a line down to perpendicular. So on my front view, this is where it's going to end. So what I can do is use a trim, select this boundary, trim that off, right click, repeat, and trim. We also have to adjust the cylinder here because this bottom piece actually hides that cylinder, or it goes into it. So what we need to do is just take this and then bring it up like that. And that view is almost complete. We have to show a hidden feature of that slot that passes through that vertical flange. So it shows that the center of it is 22 millimeters from the bottom. So we'll go offset, type 22, bring that line up. So this line is going to represent the center line. So what we'll do is trim it off. Here's the boundary, trim. And we are going to come back and finish that later once we have the right side view built. It'll be easier to finish this off once this right side view is completed. Now this flange here on the base, it's not as wide as the cylinder. It's 27 millimeters per side. So basically if I add that up, it's 54. The largest cylinder is 64. So if I subtract 54 from 64, I'm going to get 10. And I need to break this up over two sides. So 10 divided by 2 is 5. So it's going to be 5 per side. So what we're going to do next is we're going to offset this line and this line inward 5 millimeters on both sides. So we're going to click offset, type 5, enter, like this, and then the height of that vertical flange is known as 33. So again, I can offset, type 33, bring that line up. And again, we have some trimming. So we're going to trim, select these lines, right click, and trim. All right, so that flange is starting to be defined now. It also has a radius on each side of it. We talked about this earlier in the lesson. There's a radius of 7 on both sides of the vertical flange. So what we're going to do is, this is something we've looked at before. We used it for a chamfer, but we're going to use it as a fillet now. So we're going to select fillet. It defaults to fillet. You don't need to change it by dropping the arrow. Select fillet. It gives you some options, right? It's undo, polyline, radius, trim, multiple. We want to select radius. So select radius and then key in 7, enter. And then select this horizontal line and this vertical line, and it will create the radius for you. We can right click our mouse, left click repeat, select this line and this line, and it does it again for us. Pretty slick. All right. There's another slot going vertically through the flange, so we need to find the location for that. So we're going to offset from the bottom horizontal line up 22. So here, at the midpoint of that line is going to be where we're going to draw our next circle. So this is a radius circle. So what we're going to do is this time grab center radius, find the midpoint of this, and type 6, enter. Right? If you had picked this as a diameter, it would be too small. So it's dimensioned as a radius circle on the drawing, so that's why I switched this back to a center radius circle. Next thing we're going to do is use our line, find the quadrant, come up to perpendicular, both times, and we're going to trim. So we're going to select the trim tool. We're going to select these lines as boundaries. We're going to right click, select this part of the circle to trim, and this line to create the slot. And we have it. We have one more. We still have some hidden lines we still have to add to this drawing. So we need to draw a line from the bottom of this slot and bring it over to the front view, the perpendicular. Now this is going to represent the bottom of that vertical slot. This is going to represent the center line of it. This is going to represent the bottom of it. So we're going to trim this here, select that line, turn it into a hidden line. And we also have to do the same thing for this right side view. This horizontal base is hidden from our view when we look at this from the right, which is this part right here from top to bottom. So we're going to draw another line from here over. Now this line is only going to pass through the flange. It doesn't pass through the cylinder, so it doesn't make sense to have the hidden line continue beyond these two boundaries here, these two lines. So we're going to trim this off here at this line, and this line is going to become hidden as well. Okay, one last thing we need to do is finish off these center lines. Now, again, center lines are not a part of the drawing. They're a part of a drafting standard. So anything that is circular or has symmetry requires a center line. So we're going to pick these two lines here, place them on the center line layer, and then center lines have to extend beyond the feature that they're attached to. So the note on the hub tells us that it's 6 millimeters. So we're going to take this and use a grip and extend it 6 millimeters. So why is it 6 millimeters? Well, why not 5 millimeters, right? Some people say, well, that sounds a little more even and easier to remember. Well, in an imperial drawing, they stick out about 1/4 of an inch. So if you do a conversion from imperial to millimeters from 1/4 inch, you get 6.35 millimeters. And the reason we go with 6 millimeters is because it's easier to remember, right? We just round down to the nearest whole number. So it's better to say 6 instead of 6.35. This line here also becomes a center line, and it gets gripped out 6 millimeters per side. I just selected the wrong line. Okay, so we've got that one done. We also need to add a center line here as well. So we're going to create a line at this midpoint because that cylinder is round, right? Otherwise, it gives us a perspective of being a square block, and it's not. It's actually round. So this requires a center line too. So we're going to select this line, use a grip, 6 millimeters in each direction. Change it to a center line. And again, instead of redoing it over here, I'll just copy it. So we'll copy it from this midpoint to the midpoint on the right side view. And lastly, this line is a center line. So it needs to be turned into one and then adjusted. So we're going to select it, select center line from the list. We're going to bring it back to the endpoint on each side. And 6 millimeters each direction. 6. Now you're going to notice something here, or maybe you won't. Undo. Again, I can't hit escape. Drives me crazy. Anyway, this center line doesn't have the dash in it. Even though I've adjusted it, it's 6 millimeters each direction. It doesn't get the intermittent dash every so often like the other center lines do. So we have to adjust our LT scale. So this is going to make the dashes appear more often everywhere in the drawing, even the hidden lines. So in the command line down here, if you type LT scale, one word, enter, the scale factor is set for 0.5. So let's cut that in 2. Let's make that 0.25. Enter. All right, you see what that's done everywhere? So now our hidden lines appear more often. Our center line dashes appear every so often a little more. And now that looks a lot more proper, right? So it's not confusing as to whether that's a center line or what. So that completes that. So if we're going to take a look at the drawing again, make sure everything looks proper, all the views are done, you should be able to run a line from every feature on the drawing back and forth, and every feature should line up. Of course, I'm not going to do that, but that's something you can do to check your work. And that is how you complete the very first orthographic drawing. So I'd like you to try this now. Practice your commands. If you need any help, please give me a hand and call me over and I'll be glad to assist you. All right, take care for now and talk to you soon.